bit. But today's class, I'll be showing you some problems on binomial theorem which you have to do by using binomial theorem, by using its general term concept. Without wasting time, let us revise the formula before we solve sums from binomial theorem first. This binomial theorem is actually expansion of this binomial term when index is more than 1. It may be 2, 3, 4, I have explained. And the formula for expansion with the coefficients starting from beginning is nc0 x to the power n, nc1 x to the power n minus 1, y. All this you know. I just remind you that those coefficients come one after the other. Every term, sum of those indices of x and y is equal to n. nc0, nc1, ncn, these are called binomial coefficients. And how many terms are there after expansion? This you know, n plus 1. And terms equidistant from the beginning and from the end are equal. That is NCR equal to NC n minus R. And the general term which we have denoted by TR plus 1 for this binomial is given by NCR x to the power n minus R y to the power R. This plays vital role in solving problems on binomial theorem. Now, the use of general term of binomial expansion is for determining the middle term. If in the binomial expansion the index is n, you know number of terms after expansion is n plus 1. Now if n is even, then there will be one middle term only. This is very common idea. Suppose the index n is 8. Then how many terms you get after expansion? 8 plus 1, that is 9. So which one is going to be the middle term? That is the fifth term. Why? With 9 you add 1 and divide by 2. Similarly, if n is even, the number of terms after expansion will be n plus 1. You add another 1 with this, n plus 1 plus 1. Divide the result by 2. That is n by 2 plus 1th term. This is the only middle term. But if n is odd, then how many terms are there after expansion? Suppose n equal to odd means 2m plus 1. Then how many terms will be there after expansion? 2m plus 1 plus 1. That is 2m plus 2. In this case, two middle terms will be there. One is 2m plus 2 by 2th and the other one is 2m plus 2 by 2 plus 1th. Alright. So it is m plus 1th and m plus 2th. But what is m over there? Because you have taken n is equal to 2m plus 1, so m is n minus 1 by 2. So now if I put m equal to n minus 1 by 2, this is going to be n minus 1 by 2th plus 1th term and n minus 1 by 2 plus 2th term. Okay. On simplification, this will tell you n plus 1 by 2th term and n plus 1 by 2 plus 1th term. So these two middle terms are given by this and this by using NCR x to the power n minus r, y to the power r. Okay. But when you are solving sums, you can use this as formula that if n is odd, then I have two middle terms nc n minus 1 by 2 x to the power n minus 1 by 2 y to the power n plus 1 by 2. Or the next one nc n plus 1 by 2 x to the power n plus 1 by 2 y to the power n minus 1 by 2. I remind you the concept of Pascal's triangle also. At any stage, if you don't remember the coefficients of the binomial, this is of great help. Like x plus a to the power 2 is there, these are the coefficients. This I have already explained. I just remind you, when x plus a to the power 3 is there, these are the coefficients. When x plus a to the power 4 is there, these are the coefficients. So x plus a to the power 4, as you have seen before, it is x to the power 4, 4c1 x cube a. Next one, 4c1 means 4. You can write 4 also without writing 4c1. If Pascal's triangle helps you, without writing combination, you can write just 4 x cube a plus 6 x square a square plus 4 x a cube, and the last one is a to the power 4. So expansion will be easier at any stage if you keep this Pascal's triangle ready with you. Okay, now let us start solving sums on binomial theorem. But today's class I will be discussing text-based sum, like the sums is normally found in NCERT and NCERT exemplar book. The first set of questions will be like this: how many terms are there in the expansion of a plus b to the power 8? Here index is n. So as n equal to 8, number of terms n plus 1 equal to 8 plus 1, that is 9. Everyone can state number of terms. Here will be 10 plus 1. Here it will be whatever may be the term in the binomial, 2p, 5q, it doesn't matter. Number of terms going to be 6 plus 1. And here how many? All these are very easy because binomial are there. But in this case, it is x plus y plus z to the power 12. How do you find number of terms? So let us start this manner. It is x plus y plus z to the power 12. We are taking this one as one term and x as the other term. I mean x is the first term, y plus z as the second term. So if we go by binomial expansion, it is 12c1 x to the power 11 y plus z. Next one, 12c2 x to the power 10 y plus z whole square. It continues this manner, and the last one is z to the power 12. All these terms are distinct. You will never get x to the power 12 in the following terms. You will never get x to the power 11 into y apart from this one. Similarly, x to the power 10 into 2y. So these are all different terms. So how many different terms you got in the first case? If you consider x to the power 12, how many different terms are there? Just one term. Because x to the power 12 is one term only. How many terms are there? It will be 2 in number. How many are there in this case? It will be 3 in number. Next one 4, 5, 6. This manner it continues. And the last term, it will not be z to the power 12. It will be y plus z to the power 12. Make this term here. So how many terms are there? 1, 2, 3, and the last one is 13. All these terms, if you add, total number of terms going to be 1 plus 2 plus 3 up to 13. So there will be 13 into 14 divided by 2, that is 91. So number of terms 91. Okay, let us solve. And in the next type of sum, let us solve number 1 first, that x to the power 40 in the expansion of 1 plus 2x plus x square to the power 27. So in this sum, actually it is a trinomial. 1 plus 2x plus x square to the power 27. It can be reduced to a binomial. 1 plus x whole square, this to the power 27. So it is 1 plus x to the power 54. Question is how to find the coefficient of x to the power 40 here. How will you start? You will start this manner. Let x to the power 40 comes in TR plus 1. What is TR plus 1 here? This is nothing but 54 CR into x to the power r. This you know. For 1 plus x to the power n, what is coefficient of x to the power r? I mean TR plus 1 is what? It is NCR 1 to the power n minus r x to the power r. 1 to the power anything is 1. So it is NCR into x to the power r. So whenever 1 plus x to the power n is there, coefficient of x to the power r will be NCR. Coefficient of x to the power 10 will be NC10, like that. So TR plus 1 is this. Here you have expected r x to the power 40, but you got x to the power r. So this implies r equal to 40. So what is the coefficient here? Required coefficient is 54 C40. In any exam in this world, evaluation of 54 C40 is not required. You never try to do it. Next one, let us find coefficient of x to the power minus 15 here. Here also we need to use the concept of general term. We will start this manner. Let x to the power minus 15 occurs in TR plus 1. You find TR plus 1 here first. TR plus 1 is what? 10 CR 3x squared to the power 10 minus r minus 4 by 3x squared to the power r. So this is nothing but 3 to the power 10 minus r into x to the power 20 minus 2r minus 4 by 3 to the power r x to the power minus 2r. My concern is about the index of x. Whatever index we get here, we will compare with minus 15. If we get r as an integer, then it's fine. If you don't get r as an integer, we will say that such a term not possible. So let's see what happens here. It is 10 CR 3 to the power 10 minus r x to the power 20 minus 4r. What did you expect there? X to the power minus 15. But you found the general term here. So compare 20 minus 4r with minus 15. So we are getting 4r equal to 35. R is becoming a fraction. Not possible. A term cannot be 35 by 4. So your answer will be what? Such a term your answer will be like this. Such a term in this binomial expansion never occurs. Understand? So x to the power minus 15 is not a term in binomial expansion. I mean x to the power minus 15 does not occur in a term in binomial expansion. Alright. Now how to find the term from beginning and end of binomial expansion? This is a very important question. I mean very important information about general term is required here. That is fourth term from beginning and fourth term from the end in the expansion of this. Fourth term from beginning, when you are finding T4 we can find easily just by writing this one in the form of general term, that is T4 as T3 plus 1. T3 plus 1 is what? NC3 x to the power n minus 3 2 by x to the power 3. Simplify, you will get x to the power n minus 6 into 8. No need to simplify because n is unknown over there. So we keep our answer this far. But the next part of the problem, how to find fourth term from the end in the expansion of this thing. Let us find it, fourth term from the n. Fourth term from n you can't find easily. If you go by textbook formula, it is n minus p plus 2th term from beginning, it will be in confusion. So it is better to start this manner. You take 2 by x as the first, x as the second. So when you are saying it is the second term, fourth term from n, it means fourth term from beginning of this expansion. We have just exchanged their places. So now we will find the fourth term from here, from the beginning, where 2 by x is the first term. So required one going to be nc3 2 by x to the power n minus 3 into x to the power 3. So this is nc3 2 to the power n minus 3 this into x cube. So nc3 2 to the power n minus 3 by x to the power n minus 6. This is the fourth term from the n. What we did there, we just exchanged their places. In place of x, we bring 2 by x. In place of 2 by x, we take x. Okay. Next, let us find the middle term. No, term independent of x in the expansion of this thing. Root x by 3 plus 3 by 2x squared to the power 10. So again we take the help of the general term. We write the general term and from there we can quickly decide. This binomial is x by 3 to the power half plus 3 by 2x squared to the power 10. So we'll start this manner. Let tr plus 1 be independent of x. Now what is tr plus 1? It is 10cr x by 2 to the power half. So this is ncr e to the power n minus r. So it will be n minus r by 2 and 3 by 2x squared to the power r. So write this one as 10cr x to the power n minus r by 2. This is 3 by 2 to the power r x squared. Denominator, it goes up as x to the power minus 2r. Why do I need to do it? I want to find the term independent of x, where index of x will be equal to 0. And remember here n is equal to 10. So finally here when you are calculating, we will replace n by 10. Before that, you write this as 10cr by 2 to the power n minus r by 2, 3 by 2 to the power r, x to the power n minus r by 2 minus 2r. Okay. So here x to the power this thing, that is n minus r by 2 minus 2r, this thing will not be there because it is stated that it is independent of x. So put this thing equal to 0. So n minus r by 2 equal to 2r. So n minus r 5r. No, it is 4r only. 4r. And n is 10. So 10 equal to 5r. R equal to 2. So the third term doesn't contain x. It will be absolutely free of x. So your answer will be that, the third term. And really by putting n equal to 10 here and r equal to 2, you can find that it is 10 minus 2, that is 8 by 2, that is 4, 4 minus 4, 0. So x will not be there. And then required term will be independent of x, but your answer will be required term, it may be independent of x, but there are other terms you need to write apart from x. It is 10c2 into 3 by 2 square 2 to the power 10 minus 2 by 2. You simplify or not? Alright. This sum is based on your manipulative power, because you have to manipulate a lot to get the answer. Term independent of x in the expansion of this. You will start this manner only. Let tr plus 1 be independent of x. You write tr plus 1 here. Tr plus 1 is what? 2n cr x to the power 2n minus r 1 by x to the power r. So this is nothing but alright, 2n cr index will be 2n minus 2r. This r will take up. Now they ask you to find the term independent of x. So there will be no x over there. If it is independent of x, then we must put 2n minus 2r equal to 0. So r equal to n. Therefore, tr plus 1, which is nothing but tn plus 1, is independent of x. Really, if you put n equal to r over there, x to the power 0, it will be 1. No x will be there. Now the problem is to evaluate this one, because they asked you to find the term independent of x. No x is there, but absolute term is there. Why no x? It is given by what? 2n cn. Required term is 2n cn, which is nothing but 2n factorial, n factorial, n factorial. We will try to show that this one is of this form, 1, 3, 5, 2n minus 1, like this. How to? We are just simplifying it. We are writing this one as 2n minus 1, 2n minus 2, and this is, say I am writing 6, 5, 4, 3, 2, 1. Why? You will understand easily. It is factorial n, factorial n. Now what we are going to do there? We are collecting all odd terms. You see, odd terms are there and one factorial. We will keep them separated. So we start writing from the end, all the odd terms. 1, 3, 5, 7. This way 2n minus 1, the last odd term, and factorial n separated out. Now from all the remaining even terms, what you are doing there? Even term means this 2n. 2n is one even term. 2n minus 2 is one even term. What we are doing, from all these even terms, we are keeping it 2 common, 2 out. So if we take 2 out from here, it is 2 into what? N. Take another 2 here, 2 into n minus 1. So you collect all these 2 first. How many times it will come? Because 2n terms are there. 2n even terms or 2n plus 1. This you have to decide whether 2n plus 1 or 2n. See, any factorial starts with 1. It is product of first n natural number if factorial n is there. So when you are getting 2n factorial starting from 1, so 2n terms are there. Out of these, n even and n odd. N odd terms are already taken here. So n even terms will be there. From every term, I am taking 2, 2, 2 as common. So there will be up to n times. This multiplied by what is left over there, n minus 1, 3, 2, 1. This by factorial n. See, this one is factorial n, they get cancelled, and we are getting finally here it is 1, 3, 5, 7 up to 2n minus 1 multiplied by 2 to the power n by factorial n. Alright, you all understand? Now let us see how to find the middle term in the expansion of x minus 3 by x to the power 10. For this kind of problem, I told you need to find number of terms, then you use formula or direct calculation. It's up to you. Here number of terms after expansion is 10 plus 1, that is 11. So the middle term is T. Which one is the middle term? Number of terms 11. It will be 11 plus 1 by 12. That is 6th. T6 means what? T5 plus 1. This is nothing but 10C5 x to the power 10 minus 5 minus 3 by x to the power 5. Go on simplifying. It will be 10C5 minus 1 into 3 to the power 5. No need to simplify further. Keep your answer till this. This is for number 1. How to do number 2? How many middle terms will be there? Here number of terms after expansion 9 plus 1. This is 10. So that formula you apply. It will be the middle term. There are two middle terms. One is T 10 by 2 and the other one is T 10 by 2 plus 1. This is T5 and T6. What is T5 in this expansion? You know how to write. T5 will be T4 plus 1, that is 9C4, 3x to the power 9 minus 4, 5, and minus x cubed by 6, this to the power 4. And T6 is T5 plus 1, it is given by 9C5, 3x to the power 4. On simplification, you can get these two middle terms. But next one is very challenging. How to find middle term here? You just write this one as 1 plus x whole cube. This thing is 1 plus x whole cube, whole thing to the power 2n. So this is nothing but 1 plus x to the power 6n. Alright. So how many terms are there after expansion? 6n plus 1. So only one middle term, because this one odd, only one middle term here. Which one is that? One middle term is T 6n plus 1 by 2n. That is 3n plus 1n. T 3n plus 1. This is nothing but 6n C 3n x to the power 6n minus 3n. You simplify or not, it doesn't matter. This is the answer. There is one middle term. Thank you. Next session, I'll be discussing different other types of sums from binomial. This session I promised you that ordinary sums from textbooks will be done, and that I hope you have understood how to start sums from binomial theorem from your textbooks.